Okay, I forgot a very important problem, so I'm going to go back and do it. This one is problem 28, chapter 2. Let me answers to the selected problems, which it's not there because that's why I didn't pick it originally, because it's not one of the ones you have the answer for. But I know the answer, so that was very silly of me because it's a very good problem. So this problem, you've got this pipe. I'll try to draw it. Kind of looks like this. And well, the interesting thing is that it's got a fluid here that ends here. This fluid is not water. Okay, we're told that this here is 50 mm. That here to here is 120 mm, and that this is 100 mm. And then we're also given 3 points: one here, and one here. We're told the distances for these as well is 300 mm and 250 mm. So this is all water. Okay, this whole bit is water. This part is mercury, and we of course are not given just the densities. We're given this, like the specific weight is 13.55 and 0.957. Now remember that S is equal to gamma, or it's actually equal to both gamma and P, or density over density W. We know that the density of water is 1,000 something like kilogram meter cubed, something stupid like that. The units aren't as important, so all we need to do to get these back to density is multiply these by 1,000. So now we've got gamma W, or sorry, rho W and then rho HG. Sorry, I forgot the HG here and the W here. So this is going to be 957. This is going to be 1355. Now we've gotten the setup. So what's the actual problem? We want to know ACB. We have a point D and point E. We want to know P, pressure at B. All right. So this one's really neat, and I'll show you why this one's so good, because we're basically going to chase the flow of the fluid down from, you always want to do this, from PATM, okay? We don't do it from the top of the liquid here, because we actually don't know where the top is. It doesn't tell us where, okay? But we do see that this right here is an opening. Okay, this is out towards the atmosphere. So we're going to start here. We're going to work our way down over to here in the straightest line possible from point to point. So that means we're going to have to go from point E to point D. Now, some other things that you're going to have to remember is that P is equal to rho G H, and that delta P is equal to rho G delta H. But I think we're going to stick with the top one here for now, and you can simplify it a little bit more with the second one, but it works just as well if you just do the first one. So first we're going to need to find pressure at E. Okay, then we're going to need to find the pressure at D, then the pressure at C, and then the pressure at B. Using this equation here, we know that this is going to be rho GH, but the H, all right, for the first one at E, it's not below anything. So it's kind of negligible, sorry. So it's 0, okay? Or atmospheric. It's really atmosphere, but we're measuring gauge pressure, not absolute pressure. So just remember that it's 0 gauge or it's atmospheric pressure. So now at D, well, what's the height difference here? Change in pressures, change in height here. So this is going to be 120 minus 50. But you also have to remember this is in millimeters, so it's actually 0.120 minus 0.05. Sorry, it is not. These are the same height. I just drew it poorly. My apologies. So what this is going to be rho of Hg, because it's mercury right here, times gravity, times H. And the H is, sorry, is actually just 120. If I was doing to C, it would be different, but we're not, so don't worry about that. So this is going to be delta H, or in this case, just H, which this is going to be equal to 13,550 times 9.81 times 0.12. Next, we're going to have this one. This is C. So from D to C is now what we're going to be measuring. And notice it's no longer mercury, now it's water. So it's going to be rho water times G times, now you see how we're not going down, we're going up. We've already established that going down is positive. So if going down is positive, going up is negative. So now our delta H here is actually going to be negative. So this is going to be equal to 957 times 9.81 times a negative 0.05. I believe it should be point. Yeah. So now for C to B, this is going to be rho W times G times delta H, which is going to be equal to 957 times 9.81 times 250, or in this case, it's going to be 0.25. I forgot something. Every time we do this, we've got to add on the one before, plus PD, plus PC, plus PE. All right? So that's a very, very important step. Don't forget this. This is probably the most important thing you learn from this, is actually this final thing, is you add these. So when you're coming from here to here, here to here, you add, you add, just like that. And this will get you your final answer here, but let's start going through this. So this is 13,555 times 9.81 times 0.12. This is 1595. Now our 957 times 9.81 times our negative 0.05. This is going to be negative 469. And then we have 957 times 9.81 times 0.25. This is 2347. Okay. So now when we add these up, remember this is going to be plus 1595. So let's add those together. So this is actually 1125. And now these have to that's correct. 11,550. Sorry. Now take this, add it. Yeah. This is actually 15,481. My apologies. Yes, okay. Now add these together. So we have our 230, 2347. Add this to this. There it is. We've got 17.8 or 17,828 PA, which is 17.8 kPa. Now I'll go through this because I think I explained it really, really terribly over here. So you take this as P atmosphere. All right, that's point E. Point D is the change in height. Okay, it's rho hg times gravity times the change in height from here to here plus this pressure. Okay, that's your point D. From D to C, it's rho g of this fluid that's between the two times the distance and height between the two plus this pressure. With C, it's going to be the same thing. Okay, you keep going down the line until you're here, distance between these two. The rho of the water, or whatever is between the two, times G, and add to it C every time you go down the line. So this is our final answer right here. PB is 17.8 kPa. This is my first one I did of this problem, my rough sketch. I think this is actually much more clear. So please take a look at this. Except I used 1,000 instead of 957, so the answer is a little bit off. Why was my rough sketch so much clearer? Please just take a look at this instead. Thank you guys for watching. I hope this helps and didn't confuse you.